So we are going to be taking notes in section 1.1, which is graphing quadratic functions in standard form. For those of you who have not used Notability before, you're going to download the notes from Google Classroom and they're going to go to your Google Drive. Once you're in Drive on your iPad, you click the three dots in the right top corner. You're going to send a copy and you're going to send that to your Notability. You're going to create a new note. And then in those notes, the note title should already be filled in as Chapter 1.1 Notes. The subject, you're going to send it to your Algebra 2A Notes. You should have made a tab that looks like that, and you're going to import all the pages. So then you hit the top right, Import, exit your Google Drive, go to Notability, and it should show up right there. So like I said, this is section 1.1. Our essential question here is we want to know about the properties of quadratic functions. So all through Algebra 1, you were talking about linear functions for the most part, which are those straight line functions. Chapter 1 is all about functions that are quadratic, so it's an x squared term, and it makes this what we call a parabola. It's like a U shape. And we're just going to learn all the things we can about that. So let's make this definitive here. A quadratic function is a function that can be written in standard form, which we'll talk about what that looks like, and that is y equals ax squared plus bx plus c, where a is not equal to 0, because otherwise we'd still be talking about linear functions. We call the graph of this, so the graph of a quadratic is called a parabola. So that's that U shape. I'll underline that vocabulary term as well. So this right here is our standard form of a quadratic function, I should say. And that's what we're going to be working with for the most part. This dotted line right here, we call this the axis of symmetry. So think of the body of a butterfly. Right? It splits that butterfly into two equal parts. That's what our axis of symmetry is. You can abbreviate that as AOS, do often, and it's always labeled as x equals some number. This right here, our next bubble, this is pointing to the y-intercept, where we cross our y-axis. And it's one of our key features of these graphs, and these are labeled as an ordered pair, some kind of x and y. Our parabola, like I said, is that U shape. And then we have the vertex here at the bottom. So this is our vertex. In this case, it's a minimum, but it can be a max or a min. Can't be both. In this case, it's a minimum. And we label this also as an ordered pair x, y. So the pieces that we're going to be working with the standard form, and we're going to learn how to find the axis of symmetry, the y-intercept, and the vertex. So first, let's visit this idea of a parent function. So remember, parent functions are like the simplest versions of a function. So the simplest version of a linear equation, one of those straight lines, is just y equals x. The simplest version of a quadratic function is just y equals x squared. So let's look at what that looks like, because we're going to compare all of these graphs with our parent function x squared. So I have these tables that are kind of like 3 columns. This middle column is just for you to plug in the numbers here. So if we have f of -2 equals x squared, we would write this as -2 squared. Remember, when you square a negative, it becomes positive, so this is just +4. -1 squared, again, would be positive, so it'd just be a 1. 0 squared would be 0. 1 squared would be 1, and 2 squared would be 4. Notice something interesting happens along this part right here. These are all the same values, and they're going to be the same around our axis of symmetry. So let's see what that looks like here. So when we graph this, as long as you're counting by ones, I'm okay if you don't label your x's and y's. But if you choose to count by something different to make the viewing window better, that's fine. You just need to tell me you need to label then so I know what you're counting by. But in this case, I'm just going to count by ones. So we have a point at 0, 0. We'll have a point at -1, +1, a point at -2, +4. We'll then have a point at 1, 1, and at +2, +4. I'm going to try and connect these as smoothly as possible. Remember, it's not a straight line. It is going to be curvy. So let's find some information about this. First of all, we can label the things we had before. So this point right here is both our vertex, and actually it's also our y-intercept in this case. And then we have down the middle our axis of symmetry. Notice for this axis of symmetry that the distance between any 2 points is going to be the same between that axis of symmetry. So we're going to use that as a trick for graphing here. So to summarize what we have here, our axis of symmetry, remember it's always x equals a number. In this case, for our parent function, it's x equals 0. Our vertex is at 0, 0. And in this case, our vertex is a minimum. Our y-intercept is also at 0, 0. And let's talk about domain and range. So hopefully you remember domain and range. Domain is all the values of x that are possible. And good news here for quadratic functions, the domain, I don't know how to make this go away. Oh my goodness. The domain is always going to be -infinity to infinity. Our range is where it gets trickier. So the range, make sure you always put the minimum to the maximum. So notice range is all our values of y. So if I were to highlight, from here up are all our values of y. So that means that the minimum value is at 0 and the maximum is at infinity. A reminder about this notation, the parenthesis means it's not included because we can't actually include an abstract idea like infinity. But 0 is included in this. So for the values that are included, we use a bracket rather than a parenthesis. So our domain is -infinity to infinity, and our range is 0 to infinity. So let's graph one of these using this table, and then we're going to compare it to our graph of y equals x squared, our parent function. So for these, I always start with 0 in the middle, and then usually it's good enough to count just 2 on either side. And you could choose different values on either side. Just make sure if you go -1 that you then have a +1. If you went -4, you have a +4, and so on. You also don't want your values to be too big because your y will be too big. So if we do this, let's start with -2. So we have y equals 2 times -2 squared. In this case, that would be 4, which would be 8. Okay, that's our first value. Second one, 2 times -1 squared. So it would be 2 times 1, which is just 2. And then our third value, y equals 2 times 0 squared, which would be 0. All right, now I'm going to show you 1. For x equals 1, it should be that y is 2, because remember we have this symmetry. But let's just double check. So we have y equals 2 times 1 squared, and sure enough, that gives us 2. And then if we plug in 2, it'd be 2 times 2 squared, which is 2 times 4, which is again 8. So notice that kind of tells us where our axis of symmetry is, which tells us where our vertex is, and actually our y-intercept for this one as well. I don't know why I didn't draw lines here, but let's draw some lines here. It's not going to be perfect because the grids are not perfect. So this is my x and y. When I graph these points, I like to start with 0, 0. Then we go over 1, up 2, to the left 1, up 2, to the right 2, and then up 8, 2, 4, 6, 8. And then same thing over 2 to the left and up 8, 2, 4, 6, 8. Right, and then I'm going to connect these. So maybe you can see here our axis of symmetry right down the middle. So it's just x equals 0. Our vertex, which again is a minimum, is at 0, 0. And I'm going to label that it's a minimum. Our y-intercept is also at 0, 0. Our domain will always be this. It's like a freebie question, negative infinity to infinity. And our range, we start at 0 on the bottom up to positive infinity. So this looks a lot like our parent function, but if we graph our parent function, I'm going to do that in blue. Remember, the parent function was at 0, 0. It was at 1, 1 and negative 1, 1. And then it was at 2, 4 and negative 2, 4. So maybe you can see here, but it looks like it's stretched, right? So it has the same axis of symmetry, vertex, y-intercept, domain, and range, but y equals x squared is wider than y equals 2x squared. So when you have that coefficient bigger than 1, it actually makes the parabola more narrow. Let's look at example 2. So we're going to do one more graphing by the table. So again, if you count negative 2, negative 1, 0, 1, 2, you can fill in your table. I already did it ahead of time, and you can do this with your calculator, which when you're in class with me, I'll show you how to do. But when you do fill that in, you should have 1, 2.5, 3, 2.5, and 1. Like I said, you can do that by hand, and I'll also show you how to do that with your calculator. So now let's get some information. Well, actually, let's graph this first. So straight line for my y-axis. Here's my x-axis. So our function was negative 1/2 x squared plus 3. We have our table on the side here. If I go to the left 2, go up 1. To the left 1, I go up 2.5. And then at 0, 3. Over to the right 1, up 2.5. Over to the right 2, up 1. So we can already see there's a big difference with this graph. So let's label. We always want to label the axis of symmetry, vertex, y-intercept, our domain, and our range. So our axis of symmetry here actually hasn't changed still. It's still at x equals 0. Our vertex, in this case our vertex is a maximum, and it's at 0, 3. So this is our maximum vertex. Our y-intercept is also at 0, 3. You're going to notice that the y-intercept and the vertex are always the same if your axis of symmetry is 0. It's not always 0. Our domain hasn't changed. That's still negative infinity to infinity. Our range is different here. Our minimum value, since this goes down, our minimum value is actually negative infinity. Our maximum y value, the highest y value that we can ever reach, is 3. So notice our minimum is negative infinity, our maximum is 3. If I graph our parent function, again it's at 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. If you want to memorize that, you can, or you can just put it in your calculator, which again, I will show you how to do. So very different here. First of all, the parent function is a little skinnier. So let's notice y equals negative 1/2 x squared plus 3 is wider and flipped. It's upside down, right? So big difference here.